Going back to pizza that we started with, the equation for making pizza is 1 crust plus 5 ounces of tomato sauce plus 2 cups of cheese yield 1 pizza. So if I have 4 crusts and 10 cups of cheese and 15 ounces of tomato sauce, and I want to know how much pizza I can make, something's going to run out first. So if I use all of my crust, I can make 4 pizzas. If I use all of my cheese, I can make 5 pizzas. If I use all of my sauce, I can make 3 pizzas. So when the sauce runs out, I can't make any more pizzas. It doesn't matter that I can make more pizzas with the other ingredients. When the sauce runs out, I can't make any more pizza. And so the sauce is what's called the limiting reactant. The limiting reactant is the reactant that is completely used up in a chemical reaction, and it's called the limiting reactant because it limits how much product you can make. Any other reactant is going to be an excess reactant. So the cheese and the crust are excess reactants. So if I have this flask here where I have 8 hydrogens, and I have 2 nitrogens. And I want to know, based on this chemical equation here, how much ammonia can be made and what flask it's going to look like at the end. Is it going to look like A, or is it going to look like B, or is it going to look like C? We know it's not going to look like A because A still has some nitrogens left and some hydrogens left. And that just doesn't happen. One reactant, just like the sauce, one reactant is going to get completely used up. So looking back to my chemical reaction there, for every nitrogen, based on the balancing, for every nitrogen, I will make 2 ammonias. And for every 3 hydrogens, I will make 2 ammonias. So if both nitrogens get used up, I will make 4 ammonias. And so flask B and flask C both have 4 ammonias in them. But there's also a ratio between nitrogen and hydrogen. For every 1 nitrogen, I use 3 hydrogens. So for 2 nitrogens, I would use 6 hydrogens. So I have 8 total hydrogens. I'm only using 6 of them. I'm going to have some hydrogen left over. And so flask C is what it would look like at the end of that reaction because that has my 4 ammonias in it. It also has my leftover hydrogen in it. I'm going to skip this. We're going to go here. So you always want to start with a balanced chemical reaction. So let's see, 6, 2, 2, 3. And in my lab, like at my lab table, I actually have 23 grams of iron and 16 grams of hydrochloric acid. And I want to know which one is limiting. There is a couple different ways that you can do this problem. I'm going to start with the 23 grams of iron. And you can either take both these reactants and convert them to the same product and see which one makes less product, like the pizza example, or, excuse me, or you can take one reactant, the iron, find out how much HCl it needs to react with it, see if you have enough HCl. I'm going to do it the first way because I think conceptually, if you're struggling, sometimes it's a little bit easier to understand. So this is just your standard stoichiometry, mole to mole step, get the numbers from the balanced chemical reaction. And I could go to either product. It just is important that I go to the same product each time. But because this question down here is asking for hydrogen, mass of hydrogen, I'm going to just go to hydrogen just because it kind of saves me a step later on. So if I use up all 23 grams of iron, I am going to make 1.25 grams of hydrogen. That's what those numbers mean. If I use up the 16 grams of HCl, so this is just like the pizzas. You know, how many pizzas could I make with the cheese? How many pizzas could I make with the sauce? Same thing, except it's iron and HCl instead of pizzas and sauce, you know? So mole to mole step, 6 mole HCl, 3 mole hydrogen, and then 1 mole hydrogen and 2.02 grams hydrogen. And so that's going to give me 0.443 grams of hydrogen. So just like when I run out of sauce, I can't make any more pizza. So that limited how much pizza I could make. I made the smallest amount of pizza I could make. I made 3 pizzas. Same thing here. This is the smaller amount of product, which means the hydrochloric acid, the thing that made that smaller amount of product, is my limiting. When I run out of hydrochloric acid, I can't make any more hydrogen. So this reaction stops when I make 0.443 grams of hydrogen. What's nice about doing this problem this way is now I've already answered this question. What mass of hydrogen can be produced? 0.443 grams hydrogen. I don't have to do any more work. So whatever the lesser amount is from when you're finding your limiting, that's your answer to how much product can be produced. So if HCl is my limiting, that means my other one, my iron, is my excess. So you're always going to have one limiting and then everything else is excess. And then to find out how much of the excess reactant is left at the end of the reaction, you have to find out how much iron is used. I know I have 23 grams of iron. So I'm going to take how much iron I have, 23. I'm going to subtract how much iron I used. That's how I find out the excess. Now, I don't know how much I used. I have to calculate it. So I know I'm using up all 16 grams of hydrochloric acid. So I'm going to find out when I use those 16 grams of hydrochloric acid, how much iron does that require? How much iron gets used up when that hydrochloric acid gets all used up? And 55.85 grams. So I get 8.17 grams here. And so again, what that means is when I use that 16 grams of hydrochloric acid, I'm also using 8.17 grams of iron. So 23 minus 8.17, 14.83. Sig fig rules, we did subtraction, so it's decimal places. So 23.0 only has one decimal place. So 14.8 grams of iron will be my excess.